Use binomial expansions, so more than one, to show that this square root is approximately this quadratic. Okay, well, we're given this formula for binomial expansion, 1 plus x to the n. So we need to try and turn it into that, essentially. And the first step is that we could write it as 1 plus 4x to the half divided by 1 minus x to the half. But be careful, we don't want to actually expand both of those because you'd end up with some sort of polynomial divided by another polynomial. Instead, we need one extra step to write it as 1 plus 4x to the half, and then 1 minus x to the minus a half, because now we're multiplying two together. Okay, so it's going to be quite involved, but it's okay. We're only looking for the terms up to x squared. Let's start then with 1 plus 4x to the half. Okay, so here, this is actually my x, and this is my n. So, and I only need to expand up to x squared. Okay, because my final answer is up to x squared. Any x cubed terms when we multiply won't come into it. So 1 plus a half times 4x plus a half times minus a half. I'm just minusing 1 from it and dividing by 2 times by 4x squared. Make sure that's in a bracket. This gives 1 plus 2x. And then I'm going to get minus an eighth here. I'm actually going to be times them by 16. It's going to become minus 2x squared. Well, use your calculator if you prefer. Okay, and then 1 minus x to the minus a half. Now this minus x is my x, and the minus a half is my n. So 1 plus minus a half times minus x plus minus a half times minus 3 over 2. Again, I'm minusing 1 from it, all over 2, just using this term, times by minus x squared. That's going to give 1 plus a half x. And then I've got two lots of double negatives actually, so I'm going to end up with plus 3 over 8 x squared. Okay, now to multiply them together, and we'll just keep this up here to keep track of it, but we can say that 1 plus 4x over 1 minus x, all square rooted, is therefore going to be approximately, because remember there are extra terms, we've just looked at the first three terms up to x squared. That's why it's an approximation. Then I'll take my 1 plus 2x minus 2x squared and multiply it by 1 plus a half x plus 3 over 8 x squared. Okay, let's get this going. So 1 times 1 and 1 times a half x and 1 times 3 over 8 x squared. And then 2x times 1, 2x times a half x, that will just become x squared. And I don't need to do the third one in this case because that would give me an x cubed term. Just work through this really systematically, and then the final one actually is going to be minus 2x squared. Let's do that again. So that will give me 1. I've got a half x and 2x, which gives me 5 over 2x. Then I've got 3 over 8 x squared and minus 2x squared. That will be 3 over 8 minus 1, which will leave me minus 5 over 8x squared. I think that will be sufficient working. Okay, we're done. So that bit's sorted. Now a student substitutes x equals a half into both sides of the approximation shown in part A to try and find root 6. Why should they not use it? It's all about our approximation, because what we've actually done is found 1 plus 4x to the half and 1 minus x to the minus a half. Now there's a condition for convergence. We must have the modulus of x is less than 1. So this one here in particular, the first one, sorry, the second one, 1 minus x to the minus a half, is okay because we just have to require that the modulus of x is less than 1. The smaller it is, the better the convergence, but that's our condition. But this one requires that 4x is less than 1. We just remember I said to replace the x here by 4x. And this means that modulus of x has to be less than a quarter. And it's not. So we should not use a half. Essentially, if you do, you won't get a good answer. However, if we use x equals 1 over 11, then this is okay because it's less than a quarter. In fact, it's quite small, so we're expecting pretty good convergence as well. Often you use things like 0.1 and 0.01 because they're easy to be squared, but we're doing 1 over 11 here. We've got our calculator to help us. If you didn't have a calculator, that's why you would want to use things like 0.1 because it's so much easier to square. Okay, so this is part 3, I think, anyway. Oh no, is it C? Part C. So let x equal 1 over 11. Right, I'm going to actually deal with the left-hand side first. So I'll get the square root of 1 plus 4 over 11 over 1 minus 1 over 11. That is 11 over 11, so I get 15 over 11 over 10 over 11, which is going to just become 15 over 10 because the 11's essentially cancel, or you can change it to 15 over 11 times 11 over 10. And then that will become 3 over 2 square rooted. Okay, remember I want root 6, so I think I've just got one other thing to do. Actually, let me times it through by 2 to make it root 6 over root 4, which I can then write as root 6 over 2. Okay, so I've managed to get the left-hand side as root 6 divided by something. So I just need to now work out the right-hand side, and I can then times everything through by 2. So the right-hand side is 1 plus 5 over 2 times 1 over 11 minus 5 over 8 times 1 over 11 squared, which is 1 over 121. I will use my calculator for that bit. So in fact, the second term is going to become 5 over 22. And this term will be 5 times 1 over 8 times 121, which gives me 1183 over 968. And therefore, root 6 is going to be approximately 2 times 1183 over 968. Now we're actually asked to leave our answer in as a fraction. So it's just going to be 1183 over 968 multiplied by 2 gives 1183 over 484. You don't get penalized actually if you don't simplify it, but it makes sense to just put it in your calculator, I think. One thing I would strongly recommend in this question is that you just check whether it's actually any good. 2.4442 is our approximation, and root 6 is actually 2.449. So it's correct to two significant figures, not quite 3, because we have 2.44 versus 2.45. But look, with that kind of accuracy, we know that we've done it correctly. Well done.